All right, so for this lesson, we're going to start talking about geometric transformations. So I wanted to kind of give you a tree map that discusses the difference between rigid motions and non-rigid motions. So we're going to be talking about a translation, which means that we're going to shift the image, we're going to reflect, we're going to rotate, and then we have dilations. Now, there are three different type of transformations that are rigid motions, and rigid motions are ones that preserve congruence, which basically means they don't change in size. We can slide them, we can flip them, we can rotate them, but the actual shape and size of the figure does not change. So a rigid motion means that these are the types of transformations that don't change the shape or don't change the size of the shape of the actual figure. Okay, so a translation simply means that we are going to take our shape and we can move it to the right, we can move it to the left, we can move it up, we can move it down. So we have what we call the pre-image. So the pre-image is the original, okay, and then when we translate it, where it goes is the new image. So just remember that when you hear pre-image, that's the original. So a translation just means that we're shifting it up, down, left, right. Okay, then we have a reflection. So a reflection, we can have all types of reflection, but again, a pre-image is the original, and that means that it's going to reflect just like it would like a mirror image over. We could do it with the x-axis. We could do a reflection over the y-axis and it wind over here. We can actually do reflections over diagonal lines. So it's going to keep its shape, but it's going to reflect. It's going to be a mirror image over whatever it's comparing it to. Then we have a rotation. So a rotation means that it is going to rotate in a circular motion, just like if a lot of times it's going to rotate around the origin. That's not always exactly what will happen, especially in other rotations, but for the most part, it's going to rotate around the origin. Think about it rotating around like a car wheel. So if it's rotating, this is going to rotate this way, okay? So again, my pre-image is my original, and then it did a rotation, and this is where it wound up. And we're going to talk about how to do all of these, but if you notice, the one non-rigid transformation is the one that does not preserve congruency, which means it's going to change shape, and that's called a dilation. So a dilation means it can make it be bigger or it can make it be smaller. However, it is going to be proportional. So proportional means that that they are all going to have the same change in size by the same number. So like let's say this was our original and then it got smaller. It has the same shape, but it's not the same size. So we can reduce the shape by, let's say, half. So like if this was 10, then that reduces to 5. If this is 16, then that would reduce to 8. And if this is 8, then this would reduce to 4. Okay, so these are all proportional to 1/2. So we have a pre-image. It is reduced or enlarged by the same number, and it's going to be the same shape, just a different size. So keep that in mind. There's 3 rigid motions that keep the same shape, or the same size. I keep saying shape. They're always going to be the same shape. It's going to keep the same size, where a non-rigid, which is the dilation, makes it look bigger or smaller. Okay, so the first thing we're going to talk about is translations. So a translation is a function and that function that moves every point of the object the same distance and in the same direction. So a translation means that we're going to have like a rule where it moves every point in the same direction and the same distance. Now, the original figure is called the pre-image, so that's super important, especially when you're reading a problem. It may say pre-image. The pre-image is the original. The figure after the shift is called the image. So after the shift, that's just called the image that you're trying to find. The result is usually denoted with a marking. Now that marking is very simple. It just looks like a apostrophe. So they may put, if they say the image is A, B, and C, or excuse me, the pre-image, let's say they say is A, B, and C, which would be something like would be a rectangle. They would say the pre-image is like A apostrophe, B apostrophe, C apostrophe. So that just means it's been moved. After each letter, which they will read it as prime, is what the terminology is called. So if I say I have the pre-image is A, B, and C, we'll say that I have A prime, B prime, C prime. Okay? So if you look right here, we have, this is our original, this is our pre-image. So if you notice, the pre-image is A, B, and C, and then A, we have A prime that goes with A. We have B, there's B prime, then we have C, and then C prime. So if you notice, and let's kind of look at how it shifted. So if I'm looking at A, I can see that A went up. So we can see that A went up, and it went up by 3 units. And then it went to the left. And then we have 1, 2, 3, 4, 5, 6, 7 units. And we are going to learn how to write the rules to this. So basically, if you notice that every one of those would do that. So basically, we're going to say that the x's, okay, we're going to wind up saying we're going to either add or subtract a value, and the y's, we're going to add or subtract a b value. So the x's are going to be left or right, and the y's are going to be up or down. So if we started at an original point of xy, our pre-image, our prime values are going to reflect what type of translations we had. So our rule here would be, for the x's, we went to the left, so we're going to go minus 7 units. These are not opposites because we are actually saying we're going to the left this time. It's not an actual function, it's just a rule. And then the y, we went up, so that's going to be plus 3. So every image now we could actually figure out without actually looking at the graph. We could say, okay, B, all right, I'm going to come over here. So B, the actual coordinate was 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So that point is 6 and negative 3. So we could find B prime if we wanted to by saying 6 minus 7 with our rule, and then y plus, or not y, it would be negative 3 plus 3. So my B prime would be negative 1 and 0, which if you notice, that's exactly where my B landed, was at negative 1, 0. Okay, so we can write rules for this, and we are going to learn how to do that a little bit further. All right, so we can describe translation by starting how the original was moved to create the image. We usually specify how far, so just like we did just a second ago, we want to know how far did it move and in what direction. Okay, so how far means how many units, and direction means up, down, left, right. All right, so describe how the transformation of the triangle ABC was transformed. So the original, or the pre-image, we've decided that based off of what we can see, that it was translated 6 units to the left. So we went left 6 units and then up 2 units. And every point is going to do that. Okay, so translations does not change the size. It just changes the location, okay? In addition to describing the transformations, we can also write an algebraic rule, which is what I was describing earlier. It can be useful to have these movement of individual points to describe it. So remember the pre-image, so just like we said before, so A was located at 2 and -1. So I'm going to kind of zoom in here. So remember, 2 and -1 was that. So we said that B was located at 6 and -3. And then C is located at 1 and -4. Okay, so that's my pre-image points. So the image points, or the prime points, if we go and we say that we're going to the left 6 and up 2. So remember, we kind of wrote a rule for that said the X is going to be left. Hold on, did I say 6 or did I say 7? Hold on, let me check one thing just to make sure I'm right, because I could be wrong. So this is 1, 2, 3, 4, 5, 6, 7. Oh, so yes, it is 7. So it's not left 6. So let me erase that. And then I'm just all kinds of messed up. And then up 3 units. Sorry about that. Okay, so we're going to be going left 7, up 3. Okay, so we have our points. So if we write our rule, so we're going to say to the left 7, and then my Y values are up 3. Okay, so for the A, if we add or subtract 7 from 2, that's going to give me -5. And then obviously if I do -1 plus 3, that's going to be at +2. And I can confirm that A is at 1, 2, 3, 4, 5, and then up 2. So that prime point is at the correct location. Same thing with the other one. So I have 6, we're going to say -7, so that's going to be at -1, just like we did before. -3 plus 3 is 0. Then for C prime, we're going to subtract 7, so that's going to put me at -6, and then we're going to add 3, which puts me at -1. So I can look at it graphically, or I can write a rule and do it that way. So, so my pattern here, and I was trying to form these, but I kind of already did it earlier in the video. So we're saying that the Y values are going to decrease by 7 because we're going to the left. So if we're going to decrease, or the Y values decrease by 7, and we know that the Y values increase because we added those, we went up, and that increased by 3. Again, our function rule will be X minus 7, and then Y plus 3. Okay, so just be mindful that those rules are just simply telling me what direction I'm going, left or right, and by how many units. All right. So in general, when we write a function rule, the horizontal shifts are first because they're x's. And of course we use x, and if it's x plus, that means we're going to the right. Remember, these are not opposites. We're physically stating the direction. So adding means going to the right, and then subtracting means we're going to the left. Same thing with the vertical shifts. The vertical shift comes second, just as a point does. And that means that if it's plus, we're going to go up. If it's subtraction, we're going to go down. All right, so we're just going to do a few examples, and then hopefully, you will be fine with these. So we're going to graph the following. So we're going to graph the pre-image, and then we want to translate it. So my pre-image is at 2, 3, and then I have 4, -1, and then 5, 2. All right, so I have this triangle here. And that's going to be my pre-image, and they want us to translate it up. We're going to translate it up 2 units, and then we're going to translate it left 4 units. Okay, so if we're going to the left, that means that my function rule is going to be x minus 4 because we're going to the left, and my y is up, so that's going to be plus 2. And again, you can do the function rule for all of these if you want to, or we can just kind of physically move the points ourselves, especially if we're graphing. So for our pre-image, that means that I'm going to go to the left by 4. So left by 4. And then we're going to go up 2. And that's going to land me at this prime or image. So I'm going to do the same thing for this one. So we're going to go to the left, 1, 2, 3, 4. And then we're going to go up 2. All right, and then that puts me at my next point. And then finally, we're going to go left 4. And then up 2. Okay. And then all I have to do at that point is connect my new ones, and that's my translated image. Okay, so this would be my pre-image, and this would be my new image. Okay, so again, we're going to translate it. For the next one, we're going to go, this one says that we're going to go down 4 and then to the left 5. So if we're going to the left 5, we're going to say x minus 5. And then down 4 would be minus 4. Okay, so if I do my pre-image, and I'm actually going to put the pre-image in a, make it a dash line in just a second, just so you can kind of have some distinction here. So we're going to graph at 1, 2, then we have 4 and 3, and then we have 3 and negative 1. Alright, so there's my pre-image. Okay, so we're going to translate this, and we're going to translate it to the left 5. So I'm going to do it for one of them, and then I'm just going to kind of count the spaces for the others. So we're going to go 1, 2, 3, 4, 5. And then we're going to go down 4. 1, 2, 3, 4. And there's my new point for my image. And you can repeat that for every single one of them. So we're going to go to the left 5. 1, 2, 3, 4, 5. And then we're going to go down 4. Same thing here. So that's going to be 1, 2, 3, 4, 5. And then down 4. Oops. Alright, and so there is my image. And again, I could have done the rules. I could have said 1 minus 5 and 2 minus 4. And I could have done the rules that way. And once I did that, that would give me my new points. So if I did that, of course, that's going to put me at -4, -2, which is exactly where we landed for that first one. So then we would do 4 minus 5 and 3 minus 4. So I'm just going off the original points. So that's going to be -1, -1. And then the last one would be 3 minus 5 and -1 minus 4, which would be -2, -5. Okay, so you can do it either way. So now we want to look at this one, and we want to look and see what the rule would be. So if I give you the graph, so in this situation it says was figure A, so figure A is the one that's dashed, it was translated to create image B. So this is the pre-image, so just keep that in mind. You've got to read carefully to make sure you know which one is the pre-image and which one is the image to know what direction you're moving correctly. So for that one, they just want to know what would be the rule. So we're going to see that we're going to go up, and then we're going to go over. So we're going to go, looks like we're going up 3, and this one 1, 2, 3, 4, 5, 6, and to the left 6. And of course that would be what we could write for a rule. So if we're going to the left 6, that would be x minus 6, and if we're going up, that's going to be y plus 3. Okay, so let's make sure I did that correctly. So from A, we're going 1, 2, 3. So, yeah, and then, so we translated here. We went to the left 6, and then we went up 3. Okay. Now, we may be asked to go backwards sometimes, so just kind of make sure that if you're going backwards, like if they give you the image and they say what was the original pre-image, make sure you are reading it carefully to know what direction. Am I starting with the original and going to the new one, or if do I have the new image and I'm going backwards to the original? So it says graph the image, so the image is the new one, of EFD, so this will be the pre-image right here. And they want us to use the rule. So if I have x plus 5, that means I'm going to the right 5. And then I'm going y minus 2, so we're going down 2. All right, so that means that we would need to, basically from every point, you could do the rule if you wanted to. Graphically, you could do it graphically. Just kind of depends on if you have graph paper. It might be if you can count. Just depends on what is more comfortable for you. So like if I have E. So for E, that is at -1 and 2. So if I do my rule, that means I'm going to say -1 plus 5. And then 2, we're going to say minus 2. Which is going to give me E prime. And that's going to be at 4, 0. So if we graph 4, 0, that's right here, which is E prime. Okay, so then I could repeat that process for every single point. Like I said, depending on what's more comfortable for you, if you have graph paper at home, it really is what works. So then we have D. So D is located at 0, 0. So we would do 0 plus 5, and then 0 minus 2, which would give us D prime, and that's going to be 5, -2. All right, so we're going to go to 5, -2. That's D prime. And then finally, for the last one, we have F. So F is located at 1, 2, 3, 4, 5. So we're at -5 and -1. So we're going to say -5 plus 5 and -1 minus 2. And so F prime is going to be located at 0, -3. So we have 0, -3, 1, 2, 3. So there's F prime. And then there is our new image. Okay. So just let me know if you have any questions or anything about the transformations or the rules, and I'll be more than happy to help.